Hello everyone, and welcome to this latest video discussion as part of the RICS Tech Partner Program. My name is Andrew Knight, and I work within the knowledge and practice area of RICS. I've been with RICS for 12 years now, and my role is to look at the impact of data and technology right across the built and natural environment. And with over 110,000 members working worldwide, right across the property life cycle through land, planning and development, construction, valuation, brokerage, finance, building operation, building surveying, asset management. It's a very, very wide canvas upon which data and tech is having a very, very profound effect. And indeed, our members also work across all the different asset types: land, commercial, residential, mixed use, infrastructure. So once again, a very, very broad area that our members are working on. And today I'm really glad to have Tomas Evans join us from Fyma. So welcome to the call, Thomas.
Thanks, Andrew. Thanks for having me.
Pleasure. And it's always nice, before we get into the bits and bytes and talk about the technology and the value that it gives to the marketplace, to hear a bit about your personal backstory and the origin story of Fyma itself, Thomas.
Yeah, absolutely. So hi, everyone. I'm Tom Evans, Head of Growth for Europe at Fyma. My career in real estate started during the kind of golden days of pre-IPO WeWork in early 2019. I was working with very large enterprise clients globally to kind of sell that flex and hybrid dream on a large basis to them. So I got a glimpse then of what technology could do to enhance the built environment, and that led me to a role with SpaceOS in the tenant experience space, where I was responsible for building out the global client footprint and basically helping them expand and grow revenue there. Since then, I've worked with a facilities management company on the automation side, and now I am at Fyma, where I'm doing my best to educate the world in AI computer vision and how it can be applied to solve really some of the biggest questions currently being asked across the real estate industry. And just on Fyma, we started in 2019. Really, we were born out of the telecoms space, but realized really with advancements in AI and generative AI in particular, that it was possible to collect utilization data using CCTV and surveillance cameras. So really, the company's been going since 2019. We've made some big advancements in the last couple of years and really started pushing this across a wide range of use cases and different verticals within the real estate space. So yeah, very excited to be here today and to have this conversation, and hopefully to impart some wisdom into what computer vision is and how it works.
Indeed. Well, I suppose that's probably my first question to you, because you've used that phrase now a couple of times, computer vision, and on first listening, you kind of understand what it means, but actually I suspect there's a lot underneath the bonnet there. So could you explain, what do you mean by computer vision and how does it work?
Yeah, absolutely. So computer vision is a field of AI technology that basically enables camera systems or visual systems to interpret or derive meaningful information and data from images or videos. And in the case of Fyma, that means we can take any internet-connected CCTV camera, what's known as an IP camera, draw virtual sensors on the feed, effectively a series of lines and polygons, and then we collect all sorts of interesting observations that come from detecting objects moving through the field of view for that particular camera. Now, that could be people, it could be cars, it could be bikes, e-scooters, buses, trucks, really any kind of moving object. And with that data, you can understand simple things like occupancy, or the count of different vehicle types accessing a certain space or a certain car park as examples. You can also detect more complex metrics like trajectory, dwell time, even human demographics, man versus woman, for example. So from a behavioral perspective, really getting a good understanding of how people actually interact with the built environment, and that really helps us collect powerful insights so we can make really important decisions. That's the what. The how, slightly more complicated. So the way AI computer vision systems work, it's kind of similar to the human brain and the eyes and the kind of connectivity there. So the brain is what's known as a neural network. It's a highly dense collection of neurons and synapses through which electrical signals travel. When we learn something new, electrical signals blast across those neurons, and they're basically stored as information where we can recall them again when needed. In the case of AI neural networks, which is what computer vision systems are, these work in a very similar way. So the camera acts as the lens or the eye through which the information is seen. The software acts as a brain which identifies what the objects are and how they move. And the way you teach computer vision systems is the way you would teach a child. So let's say that you want to teach a child how to identify a cat. You show some images of a cat, you point out all of the features that make it a cat, right? You have the pointy ears, the long tail, the whiskers, the paws. You show that child a series of images, some with cats and some with other animals. The child might point at a photo of a cow when it first starts learning. So we explain why they're wrong. And then the next time, hopefully that child points to a picture of a cat. And obviously the more we repeat that exercise, the better that child gets at pointing out the cats. And that's exactly how we train computer vision systems too. We feed these neural networks with really large visual data sets. We teach it what characteristics to look for, and then we repeat that hundreds of times until it can basically point out the objects that we need it to detect with a very, very high degree of accuracy. So I think the easiest way to think of it is basically is the automation of human eyesight.
Well, that's been I think, a very informative, almost from a general perspective around AI, about the kind of that neural network approach as to perhaps to some of the other approaches where it's more of an algorithm in terms of it. And as you say, that triggers of those kind of neurons that are used in a neural network to kind of mimic the brain. Now, I guess one of the questions that immediately comes up is obviously there's an element of quality around how well you train that kind of neural network, but what's the kind of accuracy of this? I mean, both in terms of perhaps timings and also the ability to actually correctly identify kind of objects. What's the accuracy that we're looking at here?
It's a really interesting question, and it sounds quite simple to answer, but it's slightly deceptive because there's obviously a lot of variables involved. Firstly, it depends on what it is we're actually measuring. So is it something simple like occupancy, or is it more complex like trajectory? Typically, the more complex the object is that we're detecting, the lower the accuracy is going to be. So there's that. And then we actually have to look at the cameras and the hardware themselves. So what resolution, what distance, what angle, what field of view are we working with? What are the lighting conditions? Is the camera outdoors where adverse weather might affect the vision? We've even learned through this process that cameras filming at night need to factor in the bloom from car headlights. So yeah, really an undefinable number of variables that kind of impact the accuracy here. I mean, generally speaking, when we think of any kind of sensor system, anything above 90% detection rate is good. Mm-hmm. With Fyma, our indoor models are getting on average 98% accuracy, while our outdoor models are getting around 95%, which is very, very good by most standards. It's definitely worth pointing out that no sensor, whether that's computer vision, Bluetooth, heat, movement, or even IoT stuff, is 100% accurate. There's just too many variables, too many scenarios that can impact the detection. But yeah, and if anything above 90% is still a really, really solid accuracy rate. The really funny thing I've noticed about the accuracy question is that a lot of potential clients get slightly miffed when you tell them that the accuracy isn't 100%. We absolutely need 100% accuracy. Our management team expects it. We need to make sure our decision making is flawless, et cetera, et cetera. My usual response then is to ask how they currently collect the data, and the answer typically is that most of them either aren't collecting it or they're doing it in a very rudimentary fashion. Yeah. So I like to drop the infamous Fast and Furious quote, which is that 50% of something is better than 100% of nothing, which is to say that even if you've got a system which is only 50% accurate, that's still 5,000% better than what you're currently getting, probably. So yeah, it's a funny one with computer vision and accuracy. But to be honest, most modern cameras and with the iteration of generative AI now, it's about as accurate as you can get from any other sensor solution or against any current industry standard.
And how would you sort of compare and contrast computer vision to perhaps what people are becoming quite used to, which is these other kind of smart sensors that are picking up movement and other ways of looking at the kind of metrics that you're recording as well?
Mm-hmm. Yeah, I think what we typically compare against, or what we get compared against by our clients, is it's Bluetooth beacons, it's other occupancy movement-based trackers, whether they're from heat or from Wi-Fi devices. A lot of clients are kind of experimenting with Wi-Fi connections and tracking users through that method. So yeah, there's probably a handful that I think we come up against quite a lot. It's really important for me to state as well that all of those technologies have a purpose. They serve a place. They really every solution has its own strengths, and I think actually if we can compare them together or bring them in together as part of a holistic ecosystem, they actually have much more power. But those are the typical solutions that we come up against.
And so effectively, I mean, who can use this? I mean, what's the overall audience? And I know we'll probably talk in more depth in a minute around specifically kind of real estate, but in general terms, who can be using this computer vision now?
The simple answer is any commercial real estate owner or operator that wants to either optimize operating costs, generate more revenue, or improve their user experience. Anyone like that can benefit from the data that these systems provide. Our biggest clients currently are urban planners, innovation districts, business parks, We've also got some airport and ferry terminal clients too. We've also got some really strong use cases in retail, such as shopping centres and retail parks. I would say the main criteria, or the only criteria really, is to have a clear idea in mind about what it is you want to improve, and then figure out what data point is most important to helping you get there. You know, we've seen clients extract tons of really great data, but then struggle to turn it into impact because they just haven't got a data strategy in place. So the analogy I like to use here is that it's kind of comparing it to the people who first discovered oil. So I imagine the people who first discovered oil weren't storing vast quantities of it waiting for a use case to come around. I imagine they found a way to use it first and then collected it later. And it should be the same in real estate. Think of a use case, figure out what data would help you get there, then collect as much of that data as possible to help guide that decision. Almost every real estate decision being made today fundamentally hinges on the number of people using a building or a space and how those people interact with that space. Utilization impacts every layer of how buildings and spaces are operated and managed, from cleaning and maintenance scheduling all the way through to tenant experience. So I would say almost every commercial real estate business in existence could benefit in some way by knowing even that basic insight into occupancy and how many people are there. And the fact that most commercial real estate businesses will already have CCTV cameras in place makes it even more pertinent, I think.
So in terms of the kind of advantages of using computer vision over and above other kind of sensors, is it around accuracy? Is it around, as you've just mentioned, that you may already have CCTV already? What are the benefits? Is it a case of being able to do more than one thing with a CCTV system, or is it accuracy, or are there some other things that give it an edge?
There's definitely a handful of things I would say that really give it an edge. The obvious one is that most real estate operators will already have some camera infrastructure in place, so there's no need to invest in new hardware. That's particularly relevant to prevent things like long installation timeframes, and usually obviously a lot of complexity and cost that comes with that. We also need to factor in the cost of actually putting new hardware into buildings, which has a big carbon footprint in its own right. So we can kind of negate that by using the existing infrastructure that's there. The cloud-based nature of the technology, at least with Fyma, means the deployment time, or time to data as I call it, can be incredibly fast. So we can be up and running in as little as 24 hours, which I think is pretty unheard of in real estate generally for a new tech deployment. Definitely worth mentioning, the software is very adaptable. So if a client needs to collect a new data point, or if you want to move a camera and point it at something else, it takes literally a couple of seconds to change where the sensor lines are and basically draw new ones to start collecting that new data. So there is a huge adaptability component here too that you don't typically get with normal sensors. I mean, usually when you install those sensors, it's kind of set and forget, and that's it. So there's this flexibility here too. With Fyma, I suppose we should look more closely at the AI element of it too. So the way we've built our platform is that we can train the system to detect new objects very quickly. So if, for example, you want to track the number of wheelchair users that are accessing a certain space on a daily basis, we can basically train the system using generative AI to accurately detect what those wheelchairs are going to look like based on the specific cameras and angles and fields of view in question, so that within 24 hours you can basically collect a whole new data set that you couldn't before. So again, just feeding into that adaptability piece there. We've actually got a really great example of that with Helsinki Airport. So we help them detect several of the vehicles that help service the aircraft while on stand. So the refueling truck, the baggage handling buggies, etc. I think we trained it to detect something like 6 new vehicles in 3 days, which is fairly unheard of. So very flexible around client needs and demands there. I would actually say, I mean, those are quite obvious benefits. I would say there's a couple of really overlooked ones. One is that we are repurposing or dual purposing CCTV cameras. If you think about it, most CCTV cameras sit idle 99.9% of the time, unless you need to go back and obviously retrospectively look at a specific event. They're not really being used for anything, which is crazy considering they're observing everything 24 hours a day, 7 days a week. All of those amazing observations just evaporate into thin air, which to me seems like a massive wasted opportunity. So the fact now that we can automate the feeds and effectively turn the cameras from 99% unutilized to 100% utilized is very cool. But maybe that's just me nerding out a little bit. And then finally, I would say a really big benefit of computer vision done through CCTV is the fact that it can be deployed across existing stock without any retrofit needed. It doesn't just benefit new developments. It's actually quicker to get it going in assets that are fully occupied and operational through the existing CCTV infrastructure, which I think is fairly unusual in the prop tech space. So yeah, just a few of the big benefits there, I would say.
I mean, a couple of things come to mind to ask you now, which are kind of two separate questions, but almost want to kind of put them together in the sense that you've talked about a number of kind of use cases already, and that interesting one about wheelchairs and those new kind of types of vehicles at the airport there. But it's intriguing to understand how people are actually using this data, particularly obviously in this real estate space. But as ever, and we've talked at length and really interestingly around the underlying technology, but as ever, this is around business issues, business needs, business objectives. And it'd be interesting to hear from your experience how people are using the data, what kind of data you can actually get from these systems, and then critically, how they measure that and how they measure the success. Because I always say it's not, technology for technology's sake, it's technology as a means to an end here. So it'd be great to hear those sort of interlinked issues of how do we measure success, and indeed, what do people measure when they use these systems?
Yeah, absolutely, 100%. And it's not just technology for technology's sake, and then something you can measure. It's actually around how does that fundamentally impact people's lives. So this really is the million-dollar question. So, just kind of stepping back a little bit, I think the most impactful real estate decisions boil down to three broad topics. That's optimizing costs and reducing inefficiency, generating extra revenue either through the addition of new services or through increased rent and service fees, or number three, it's improving user experiences in the built environment. No matter which of those topics you choose, the most fundamental piece of information, or pieces of information, I should say, you can use probably around how many people are actually going to use this space, this building, this area, this amenity, whatever, and how are they going to use it. If you can answer both of those questions, there's a million decisions you can make in relation to how you can achieve those objectives quicker, faster, simpler, with more value, etc. So just to give you a few examples of what that can mean, just to help validate that thinking. So if we look at retail as one use case, we had one client who found out that by keeping customers in store for an extra 45 seconds, they could increase their average basket size by 13%. So what did they do? They reconfigured the stores to make it easier to reach the tills and also reposition their most popular products nearer the entrance to hook more people in. So quite a simple observation, but one that had quite a big impact. We had a shopping center client who wanted to validate rental rates for the highest footfall store locations and use hard data to basically negotiate better rates with their anchor tenants. So there's a rent validation use case here too. If we look at innovation districts and campuses or business parks, we helped one client increase the availability of EV charging points and electric scooter parking bays just by highlighting the modes of transport that people were using to arrive at the estate. So big improvement there in the tenant experience based on actual demand. We've already touched on airports. So at Helsinki Airport, we helped them improve their passenger experience by managing better check-in queues. And if we wanted to go one step further, we could actually integrate that with real-time flight data, with terminal occupancy data, and we could provide the passengers with really accurate wait times around security and immigration. So just further helping to improve their travel experience and reduce stress during that kind of transit process, which I'm probably sure we're all very familiar with. And then if you think around the office environment or even the communal spaces in a residential block of flats, you can basically monitor those spaces to understand or identify any unutilized areas, redesign the floor layouts or amenities to really optimize that space allocation and reduce wasted square footage. Obviously, there's a whole piece we could talk around here where we integrate with BMS or HVAC systems to automatically adjust temperature and lighting based on live occupancy, and really importantly, where the occupants are actually located within the buildings. Probably a whole other topic here, but obviously there's massive potential here to contribute insight towards those really ambitious sustainability targets too. So I guess the point here is that there's just so many amazing ways that this utilization data can be used that it genuinely makes my head hurt. And also just one final point on this, I think the best bit for me is that it's usually the very simple observations that lead to the biggest impact, and actually usually the observations you expect. So yeah, it's really, really interesting space.
One thing you mentioned there, which I was going to probe on, actually back to the kind of almost technical nature of some of the challenges that so many people have now with digitization, is that there are literally thousands of applications out there, thousands of solutions for the real estate world, and it can be very challenging for clients that they end up with this very complicated tech stack of lots of things that need to talk to each other. How do you make sure that Fyma is elegantly going to fit into a tech stack? Because there is this challenge of interoperability, to use the horrible phrase.
Yeah, no, it's a valid question. I've been saying for years that one of the big challenges in real estate and prop tech is that we don't have effectively an English language that every system speaks. Every system speaks a different language. That consequently makes the integration piece incredibly difficult, laborious, time-consuming, and expensive. Fyma itself, we have an API to help us connect as easily as we can to other platforms. I would say generally when it comes to the tech stack, we do fit quite smoothly into that. Firstly, we're obviously leveraging existing infrastructure that might already be integrated. So deployment times and waste there is minimal. That's especially useful across fully operational active assets. Separately, we can pull effectively APIs or pull data into any other data, BMS or HVAC platform. That's not only to extract insights, theoretically that can and should be used to automate a lot of those behind the scenes MEP processes without any human intervention. I think that's partially happening to some extent anyway, but not in a particularly intelligent way. So as an example, you might have some operators using access card data to affect the temperature or air conditioning in the building. It's kind of rudimentary because unless you actually know where people are in the building, it's kind of inefficient, because if you're changing the temperature in the whole building, you don't actually know where people are. It's sort of, I don't know, maybe it's a slightly redundant exercise, but either way, I think being able to compare our data with that access data and just validate and cross-referencing is going to be really important to really maximizing and optimizing the tech stack and just the data that we're pulling from the tech stack to really optimize and change the spaces in a positive way. Probably a kind of long-winded question answer to your question, to be honest.
No, that's fine. I guess, you know, I think it's fair to say that you've really articulated a very compelling message about the benefits of computer vision. I guess, to be contrary, what kind of reasons are you seeing for some clients saying, no, this isn't right for us? Are there privacy issues? Are there sort of sensitivities about the way the human beings are going to react to this kind of technology being used in an asset that they're in and out of all day?
Really good question. On the privacy side of things, generally, I don't see that being too much of a blocker, because, I mean, like every company, every tech company in Europe now, we need to comply with GDPR and obviously local privacy regulations, and that's something that we've really built into the fabric of the business and the product from the ground up. For example, we never record faces, we never store any video data, we just store the metadata from the feed. And we've worked very closely with the Information Commissioner's Office in the UK and the Data Protection Inspectorate in Estonia to make sure that we're absolutely on top of that. There may be cultural considerations or geographic reasons why someone might not want this. For example, if you live in a country where CCTV perhaps isn't as pervasive as it is in the UK, or perhaps where privacy is a very, very strongly held factor. Somewhere like Switzerland, for example, may have very different beliefs around CCTV than the UK. So there's that kind of cultural piece there. I would actually say one of the big reasons why you may not want to use it is if you don't have a clear data strategy or what you want to do with that data. Again, there's no point holding a vast reservoir of anything, be it oil, water, or data, if you don't have a clear way to use it. So I would say before you do anything with any data collection tool, just make sure you understand exactly what it is you want to achieve and what metrics are going to help you get there. I think probably cost is worth mentioning here too. So I would say AI-based technology generally has a slightly higher cost, especially cloud-based. Obviously, there's a lot of R&D that goes into it in the first instance, which needs to be recouped. And then also typically costs a little bit more to operate via the cloud as you're running kind of complex calculations and analysis over vast distances. So I'd say cost is probably one consideration that needs to be factored in. Another simple reason why computer vision might not be suitable is because it might be overkill for that specific use case. So if you've got a small car park, or maybe you just want a simple counting device for a building that has one entrance in and out, we're probably going to be overkill for that. So yeah, I would say they're probably the main reasons why you might not want to consider computer vision.
Thanks, Thomas. And I guess a final question, I often ask this of people when we have these kind of discussions, is to put your kind of get your crystal ball out and give us some sense of how you see computer vision technology evolving. I mean, obviously, given its support, it's in so many ways by AI, which is in itself moving so quickly. What do you think the next few years look like?
Oh God, it's going to be so interesting. I honestly think there's such limitless potential for this technology to fundamentally deliver meaningful data that's actually going to drive massive impact. If we look at computer vision directly, I think accuracy rates and the breadth of object detection, that's going to continue to improve with every iteration. These systems are going to become trusted solutions in much the same way that BMS, IWMS, and other software has across the real estate spectrum, which I think is really, really important. You need to trust the systems you're using. Looking ahead a bit more ambitiously, one of the big topics for us right now is how do we make all of this data easily accessible for a broad range of stakeholders? How can we deliver it in a way that is going to, everyone from a property manager to a customer experience manager to the global head of real estate can access without needing to have a data science degree? Every software solution out there provides dashboards or graphs, so I think it's probably fair to say that most companies are very heavily overloaded with insight currently. So we believe that one of the ways we can unload and simplify some of that is with these chat GPT style solutions. So rather than having a human look at a bunch of dashboards or graphs and then have to interpret that data themselves, they should basically be able to type that, type whatever it is they want to find into a box or even dictate it into a microphone, and then the software should be able to pull that answer for them in a few seconds. And actually, that's one of the things we're rolling out right now at Fyma. So for example, one of our clients could ask, how many people cycled through this particular area last week? How does that compare to the week before? And in a few milliseconds, they've got that specific insight they need. They don't have to trawl through endless graphs and charts. And obviously then they can get to the decision-making piece much quicker than if they actually had to go and interpret that data themselves. So I think that's one huge advancement that we're going to see across the industry now, and that's going to up-level the accessibility of the data moving forwards. Another big one, and this is probably way too ambitious, but I'll say it anyway, is this, this kind of English language piece that we were just speaking about. So there needs to be a simple middleware platform that any system can just plug and play to. It all speaks the same language, so it really enables this kind of seamless integration piece and reduces this laborious process where we have to do a million different integrations to get these systems communicating effectively. I know there are some companies already working on that, but I genuinely think that if we can crack that, then the automation around BMS, HVAC, all of that stuff becomes infinitely easier. And a lot of the sustainability targets we've set will be achieved much quicker, at least in my opinion. So yeah, I think AI, computer vision is only just getting started. There's infinite potential for it to completely redefine how we make decisions and fundamentally how those decisions translate into impact, because that's what it's all about, right? And that's not just for owners and operators, but also for end users and hopefully society as a whole. If we can use this data to design, build, and operate spaces in a way that improves health and well-being, reduces stress, and maximizes human potential across society, and I think that's really the holy grail. So yeah, maybe slightly airy-fairy, but I think that's way just.
No, a really good articulation of some really exciting possibilities there. Well, it's been great to chat, Thomas. Really appreciate your time, the explanation of neural networks and the power of computer vision for almost every aspect of making spaces, as you say, better for the people who use them. So join us from Fyma. Thanks ever so much for your time and look forward to catching up again in the future.
Likewise, yeah, I appreciate your time, Andrew. Thank you.